Hi, welcome. So, in the last video or in the last class, we have completed number of neutrons to calculate number of neutrons and the molecular mass, right? So these are the simple things. So that's why I took for the videos. There are so many type of examples. Problems are there in chemistry, but they are interlinked with some of the concepts. So that's why directly I cannot go with any such type of problems. So these are the simple type of problems. So that's why I took those problems for last two during last two videos. So when you come back offline, then definitely we will see the number of problems. And in our chemistry, problematic part is not so important, or we might not be having so many problems as you have in case of physics. So right, so that's why, as I said in the last class itself, today we will see about the chemical reactions and balanced chemical reactions. So see, dear students, you are very new to the chemistry, and whatever the chemistry you studied during your, the lower level, SSLC or else ninth or 8th, that is very short chemistry, I can say. You just came to know that there will be a carbon. With carbon, there is a hydrogen. Definitely, carbon and hydrogen form a bond. And these things are the very common, properties of your lower level. But here, during first and second PU, we will be having a vast chemistry. That means a depth chemistry, we can say. So first of all, chemistry is nothing but always it will the doubt will come about this. What is this? This is what is nothing but the reaction, right? So what is reaction? How the reaction takes place in between any two elements, right? So if we go in depth about the reaction, then definitely the reaction is nothing but breaking of, already I have explained, I think, about reaction, just breaking of old bond, and formation of new bond, right? Formation of new bond is nothing but what? Reaction. So definitely. So if we consider, see, sir, what happens if the doubt will come, right? So what happens when, if I add stones in a vessel, and if I pour some amount of water, then is it a reaction? Of course, this, see, we'll take, experiment we will do. So this is, say, as a first vessel, and this as a second vessel. So now, what I said, breaking of old bond and the formation of new bond. That means the old bond has to break and the new product has to form, right? So that is nothing but the reaction. So now, in number one case, that means A, I have added some stones, right? And later, what I am doing is I am pouring some amount of water. In number two, second case, let us take sugar or salt, some amount of sugar or salt. Assume that we took salt. So why? Because salt, every day we do experiment in our home, right, with the salt. So assume that we took some amount of salt. And again, what we are doing is we are again pouring some amount of water or adding water. So now imagine, in first case, is there any change? The stone has become mud now after pouring water or after adding water? Definitely no. That means the before, before we are taking that stone into the reaction, what was its condition? the same condition is written even after adding a water. Is it or no? Right? Isn't it? So now, in this case, after adding water, can you separate or can you separate the salt molecules? No. So now the salt is completely dissolved in what? Water molecule. So that means, see, salt is nothing but, see, this reaction we will take. So remember, breaking of old bond and the formation of new bond is nothing but what? Reaction. So here we will see, we will check whether it is a reaction or not. So now salt is nothing but what? NaCl, and what we are doing to that NaCl, we are adding what? Some amount of water. See, old bond has to break and new bond has to form. So old bond is nothing but if I say, if I write this example with bond, then it looks like this. Ionization is very important. Once if you come to know how the bond breakage takes place in between any two molecules, then definitely almost 50% reaction is completed, right? And now here H plus, H and OH bond, right? Definitely, whenever the formation of water molecule takes place, there will be an involvement of one OH minus and one H plus ion, right? So now, as I said, electronegativity plays a very important role. Sodium is what? Sodium is a metal. Metal means positively charged species, right? If I break these, that means when we pour water, or when we add the water into the NaCl or into the salt, what happens? The bond between, that means the old bond between Na and Cl will break down, or will break, or will undergo into the ionization. One we can say ionization, right? And now here OH minus, H is, you already know, H is always positively charged species whenever it breaks a bond. Why? Because its electronegativity is nearly, zero, we can say. And now this will get positive, this will get negative. Of course, this will get positive, and definitely this will get negative. So now old bond is breaking, right? In case of B only I am showing here. So in case of B, old bond is breaking and the new bond is forming. Like how? See, now this positive will not go and bind with this positive, right? The same charges repel each other, we already know. That means this sodium will go and attack to the negative part of the other compound, right? So that means Na is forming a new bond with what? OH. So that means this became NaOH plus one more product is left with us. So now this H is, this Cl will not go and bind with this OH minus. Why? Because again the negative repel each other. So that means the only one chance for Cl is to go and bind this H plus. That means it forms HCl. Because of these two type of product formation is taking place in this case, so that's why what this NaCl is completely what combining with the water molecule, right? And now we cannot separate. Once the reaction has been took place, then definitely we cannot separate the NaCl molecule from the water. Why? Because it will form a transparent, the homogeneous mixture, we can say. That means homogeneous type of medium it will form. So that's why here reaction is nothing but clearly when you can see the breaking of old bond and the formation of new bond takes place. In reaction, one more thing we need to know, that this part, the left part from this view, The left part is this and the right part is this. The left part is always called as reactant part. Very important. Reactants, these are the reactants, and the other part of the reaction is called as a product. Right? So always in here in the left side, I mean the left side of the reaction, I mean before the bar of the reaction, there will be always a reactant or substrate, we can say, in case of organic chemistry. Why we call these as a reactant and why we call in case of I mean organic substrate, we will see later. And this part, I mean the right hand part of the, or after the bar of the reaction, whatever I mean compounds are present, those are called as the product. That means reactant has to break its bond and it has to form a new bond with the other elements or the compounds. Is nothing but what? Reaction, right? So this these reactions, why these reaction takes place, right? This is very important point. So the reaction takes place because, see, because of their stability. See, if the element or a compound is not able to form a charge on it, see, like as I said in an offline class, if a element unable to form any charge on it, then for it will be very difficult to undergo into the reaction. Why? Because it is not showing any charges. To undergo into the reaction, it has to show some activity. I mean, either it might get positive or it should get negative. Then only it can undergo into the reaction. For the reaction, we require ions. Very important. Right? We require ions. Either it may be a positive, I mean cation, or it may be a negative, that is anion, we say. Right? Positively charged species are called as cations, and the negatively charged species are called as anions. And we have discussed that when the positive charge will come onto the element, when it will come, whenever the element undergo into the loss, definitely the negative charge will dominate. I mean positive charge will dominate over negative, so that's why negative, I mean positive charge will come. And whenever the gain of extra electron takes place, definitely the negative charge will over dominate onto the positive, that means nuclear charge. So that's why the element will get positive and negative simultaneously. It is a process, we can say. Until and unless if they are unable to show a charge, then definitely the reaction will not be possible, right? So this is about general, very small discussion about the reaction. If we extend this part, then it might take 2 to 3 years, right? So you just understand the reaction is nothing but the old bond has to break and the new bond has to form, one thing. And whenever until and unless the element will not show ionic a phase, then they won't go very easily into the reaction. That means to show them we need to add water, right? For NaCl we did same thing. On NaCl there is no charge. To get a charge, we took a help of what? Water molecule. After adding a water molecule, definitely the bond is breaking down and positive negative charge is coming onto the Na as well as on the Cl. So dear student, this is all about today's class. During next class, we will see some balanced equations. The next part of this, I mean the continuation part of this, right? I hope you understood the little introduction about the reaction. Thank you.